this is just like one of the framework out of like, I don't know, so many framework out there that can help you to work with PDF, but this is like one of the framework that we are going to do the tutorial today. Hello everyone, welcome back to the channel. Today I'm going to show you how to RAG with PDF using LangChain, OpenAI embeddings, and a local LLM through Ollama. If you are ever wanted to let a chatbot answer questions about your PDF documents without hallucinations, this tutorial is for you. We'll break down the entire process step by step. You see how to load, how to split your PDF data into different chunks, embedded it with a quick lookups, and then store those embedding into a vector database. Plus, I'll show you how to use prompt. It's called Refine-chain, so your bot can improve its answer within each additional chunk it sees. So, grab some coffee and let's dive into building your own PDF RAG. Let's look at this entire diagram or flowchart. This is today's architecture that we are going to do in this tutorial. It started with your app. This one can be, your chatbot or your application like user interface where user can input a query or a question like what LLM model do they mention in this case, because I had a document about AI agent and this is my question. This query going to Chroma Vector Store. What is inside this Chroma Vector Store? It is storing the vector embedding from the PDF that we are going to feed into. So for this PDF, it can be, various kind of like type. It can be all text. It can be with images. It can be with images and table. With the case that text misses with like images and table, it can be difficult or it can be challenging for LangChain in this case to do the RAG. So that we could require like a multimodal kind of like framework to be working on like different kind of text and then images and table. In this case, this is all text. So this all text go into a chunking. Chunking here, this is also like different type of chunking, splitting, or overlapping. It depends on the type of text that you are dealing with. How long is your text? Does your text have like multiple paragraphs? And how do you like split efficiently? And this chunk go into the embedding model. The model can be, from OpenAI. If you don't have OpenAI API key, you can replace by using Hugging Face. So there are multiple embedding free model from Hugging Face, and you can just call it and then work locally. So that the embedding, now all this going to be stored within Chroma Vector Store. Then the next step, we are going to query the using the user query, and then we query the Chroma Vector Store for the most relevant chunks. If you watch my tutorial from last week when we RAG from CSV file, I return relevant chunk is equal to k equal to 1. I just want the most relevant one for my chatbot to answer to my customer. But in this case, because that's one, the CSV file, I have like a script for my customers, for my chatbot. I have like question and answer, and only one answer per question. In this case, it's the file. And this file I'm using has like 50 pages. It has like multiple different information and it can be like all over. So that's why we should, return the most relevant chunk. And then the next step is Chroma returns the top N or top K relevant chunks of text. And this is going to be the new implement compared to last week, because again, like I say, this is gonna be like a big file with like multiple pages, and the information can be like everywhere. So let's say we return the most 3 relevant chunk here. What is the refine stage? So refine stage is to let the LLM to validate the answers by using, first, we get the first chunk, go into LLM. This can be any LLM, right? And then the LLM has the initial response by using this chunk of information with your prompt. So you have a prompt that say, hey, you are a, customer service support, and then you are going to insert your customer using only the information from this PDF, let's say. So that's your prompt. And then this LLM will be using the first chunk, the most relevant information together with your prompt to provide the initial response. So this response is not going to you yet. This is their initial response. And then it's combined the second chunk. We have the second chunk, and we had something called refine prompt. And the refine prompt can be, hey, you have the first response. This is your first response. And then this is the next relevant chunk. Can you compare these two? And then give me some final answers if there is any like mismatch information, or is there anything that relevant you should add to your final response. Then it continue to iterate the third chunk, and the third chunk go into the initial. This is not going to be initial response anymore. It's going to be the second response, right? It go into the second response, and it say refine it again. Looking at your previous response with this new information, and together with all of the information you have now, give me the final response. So in here, we have 2 prompts. First is the initial prompt, and then second is the refined prompt. And then the LLM will be using twice, or, as many times to refine its answer, depend on like number of chunk or relevant document that you are retrieval. And then that final response is coming back to your app, which is the interface or your chatbot as an answer to your customers. So this is a little bit complicated. Like, why do we really need the refine stage? Why can't it just relevant chunk and then go back to the customer? Because again, this is 50 pages of information. Let's say someone asks a question. That question is all over different different pages. And then when you query and you say given the most relevant chunks, for example, like just the first one, like the very most relevant, it may miss some information somewhere out there in your PDF. So I think it kind of work for long PDF, and it work for PDF that like repeated information, or added information later on in the later section. So again, this is just like one of the framework out of so many framework out there that can help you to work with PDF. But this is like one of the framework that we are going to do the tutorial today. I just wanted to show you my PDF really quick before we get into the code. I use a book that is 53 pages long, and it talk about dopamine detox. So like, what is really all of these information you don't really need to know, but why do I choose this? Because I just wanted to make sure, like, if I choose AI agent or I choose any like large language model or like any kind of like machine learning, I'm sure that the model has its own opinions or has its own like knowledge base to answer my question. So for example, if I ask what is AI agent, how do I make sure that it's really right for my document, or it's just based on its own knowledge. So that's why I choose this kind of like a specific use case where it is like a method from the author, like how to do dopamine detox, and then there's just like multiple different steps, like kind of like a guidance, and here's multiple action steps and all of that. So I will be asking questions, specific question that relate to this document, and we'll see if the model retrieved the right information or not. I know I say this many times, but I'm going to say it again. Best practice, activate your virtual environments. So I already have one virtual environment here, which is called RAG PDF. I'm going to activate it by using source RAG PDF bin activate in order to activate. This is the syntax to activate your virtual environment. Here is our virtual environment. And a requirements.txt, all of the packaging that we need for running this RAG. So pip install our requirement. Oops. You know what? My requirement.txt where I'm at. Yep, I need to cd into my folder, and then now I can run it. Pip install our requirement.txt. It's gonna run real quick because I already installed everything, but the first time running is gonna take a little bit of time. So we have packaging install. Now let's get to the real code. Alright, so we start with load the environment variable from a.env file. What is it? It is all of the API key that we need for the project. So if you're doing embedding model from Hugging Face, you need Hugging Face token. If you doing embedding from OpenAI, you need OpenAPI key. If you are using model from DeepSeek using API, you need DeepSeek API. So all of this API can be stored in this file .env here. Alright, so we import all of the packages that we need, all the functions from the library, and then we set up the API key. So in this case, I have two, just in case, someone wanted to use Hugging Face for embedding. So you have a Hugging Face token here. If you use OpenAI API keys, you have an OpenAPI key right here. All you need to do is to, initialize your Hugging Face token and your OpenAPI key in the file .env. Alright, so we are going to use the model from Ollama. Make sure that you have Ollama right here. It's running. We're going to use again DeepSeek R1. And then this is the document, the define document pre-processing function. We have a PDF file. Remember our diagram? We are going to load first, and then we split it into different chunks, and then we embedded it. So first we load, and then we split, and then we are doing chunking and overlapping. So chunking here, I'm using a chunks up to 5,000 characters because one of my paragraph is like kind of long with like multiple different action steps. I don't want to like accidentally just cut it off and retrieve like just half of the information, for example. And then the chunk overlap here, it's like this is gonna be like increasing your runtime since like junk overlap. But if you have like multiple paragraphs, multiple like points, then I think you need junk overlap, or else when each junk size, you can miss information. So that is all about test splitting into different junk size and then junk overlap. This one can have like multiple framework or multiple method to apply. And again, this character text splitter is just like one of the method that we are using in this tutorial. You can find all of the function or the method in LangChain and then see which one worked the best for your project. And then here, now we actually, read the book, the PDF, and then we do embedding. So the embedding is from OpenAI embeddings. Again, this is like multiple models that you can use. I'm a little bit biased using the OpenAI embedding because I think it's richer in terms of like vector space, with like multi-dimension. So that's why I'm like a little bit front with this. But yeah, you can use like multiple model that is not necessary to be OpenAI. So that going to Chroma with our docs and then our embedding function, persist directory here. So why do we need to persist? I get a little bit impatient whenever I rerun the query. And whenever I rerun the query, I have to like re-embed it. And I have to, run the entire process again. So it makes sense that you persist and then you make it like a local file, local directory, and then you save all of your embedding there. So whenever you, have another query that the chatbot just needs to query from your Chroma DB, and it doesn't have to like split junk embedding all over again, especially when you have like 3,000 pages. Where's the time to wait for all the pre-processing? So it makes sure that if the pre-processing work, then just save it under your local file and then query from there, so you don't have to like go over and over again. All right. Now let's get to the part there where it's a little bit different from the last tutorial using CSV file. We have two prompts. Like, remember the diagram? The first prompt is like for the initial answer. And then a refine prompt is to make the chatbot reiterate through multiple chunks to find the best answer, or to refine the answers. So this is the initial prompt. Here's the template. You are a teaching chatbot. Use the only source data provided to answers. If the answer is not in source data or incomplete, say, I'm sorry, but I couldn't find the information in the provided data. So this is like initial one. And then that prompt go into, all of the format, which is like kind of like a format for the input prompt. This is the refine prompt. So the refine prompt take the existing answer or the initial answers. So you are a teaching chatbot. We have an answer. We have an existing answer here, and then we have the following new context for you to consider. Please refine the original answer if there is new or better information. Why is that? Because again, a 50 pages of PDF information can be all over everywhere. So let's say if you return the most relevant information into 3 different chunks, it will iterate 3 different chunks and it will see all of the information, which one has the best information, or can it combine all these 3 information and provide a better answer. So we say, if the new context does not change or add anything to the original answer, keep it the same. But if the answer is not in the source data or is complete, still say, I'm sorry, I couldn't find any information. So that is our refine prompt. So then in the refine prompt, we have a refine prompt template. The input will be the existing answer, the context, and the question for the model to reconsider its initial answers. With all that being said, it's going to the chain. This part is completely the same as, a very specific framework is going to a chain type. However, in this chain type, if you watch my previous tutorial, we only have one prompt. One prompt, which is the context and the prompt that we give to the chatbot. In this case, we have two prompts. The first is the initial prompt and then the refine prompt for the chatbot to refine its answers. Then it's going to the chain, and the chain type here is refine. Refine, again, to iteratively improves the answer based on additional context. Then also the short keyword arguments here, k is equal to 5 instead of k is equal to 1 like last time. So we return 5 different chunks. So imagine this case, chatbot will be going through 5 different iterations and find the most relevant information and then return it to you. So quite efficient, right? So the query here is, I don't know, I'm just gonna put something in the book. Cultivate and the here and now neurotransmitters, which is like something that I don't expect DeepSeek R1 already have a base knowledge about. That's why I choose this topic. Alright, like what is a cultivate here and now neurotransmitter? So I just wanna see all the retrieved information. And then the response, let's see how the response goes. Alright, now we're gonna do Python 3, and then we're going to run backend.py. Okay, let's take a look at the result. I really like this part. This part is that it's a meditation, stretching, and mindfulness is already part of the original answers, and then it's adding the contemplative walking, and this is, I believe, it's gonna be in like later chunk of the book. So the book first mentioned about meditation, stretching, mindfulness, and then it's adding the information later because of the refine prompt. Then it make the model finalize and then have a better answers with all the information that it needs. So this is the answers, and it does adding the contemplative walking and then the mindfulness practices here as the points. So this is like all the points throughout the book where the author talk about meditation, stretching, mindful eating, and then all that. And then later on, when it's come to the final end, he added it, the mindfulness practices and the contemplative walking. So here's like page 46, our page 53, where he's mentioned more about mindfulness and then contemplative walking. But then if you take a look at like the earlier part where meditation was like all over, and then all the information, so it's like basically it's like a repeating guidance but like adding more information and more details. And well, I guess here is how it's like catching up with the contemplative walking and then adding more information because we asking it to like consider all of the relevant junk and then adding more context and then more information. So I guess it worked for this type of PDF, but here's a conclusion. If you have the PDF with like table images, this may not gonna be the best fit for what you need. You need a multimodal model that can looking at like different type unstructured data. You may need like multiple chain together, multiple LLM, each LLM working on different function. For example, this large language model looking at picture, the other one looking at table, and so a lot, like different method like that. And then chunk size and then chunk overlap too. This is like work for different type of PDF. So, know the nature of your PDF would help as well. So again, this is like one of the framework and I hope it's help. We are all going to get into multiple framework later. Thank you, everyone.